Hi amazing friends, welcome back to my channel. Today we are asked to find the area of the shaded portion. Now this is a quadrant, okay, meaning that this is 1/4 of a circle, and from here to here is 12 units, and this is also equal to the radius of the quadrant or the radius of the circle. Okay, all right, now the question says we should find the area of the shaded portion. It seems or looks impossible, but this is very possible. Now let's do it together. First of all, what are we going to do? How do we achieve this? Let us analyze this diagram first. If we are asked to find the area of this quadrant, okay, sorry, the area of the shaded portion, it's going to be the area of this quadrant, the whole of this quadrant, right, minus the area of this semicircle and the area of this semicircle. Okay, so let the area of the shaded portion be equal to A. Let the area be equal to A. Now, area of this shaded portion should be equal to the area of the quadrant. Let's call it A subscript Q, okay? AQ, that is the area of the quadrant, minus what? The sum of what? The area of this big semicircle and the area of the small semicircle. So let's call this semicircle AB, the area, and the smaller semicircle AS, okay? So the area of the shaded portion should be equal to the area of the quadrant minus the sum of what? The area of this big semicircle and what? The area of this smaller semicircle, their sum. Now if we open the bracket, the area will be equal to AQ minus times AB will still give us minus AB, and minus times plus AS is minus AS. Now we have an idea of what we want to do. So let us go ahead and find the area of the quadrant, okay? Now remember that area of a circle is pi r squared. Now because this is 1/4 of a circle, it should be pi r squared divided by 4, where r is the radius of the quadrant, okay? Now this is equal to pi. Now the radius is 12, from here to here 12, right? So 12 squared, okay, divided by 4. Now this is equal to pi times 12 squared is 144 divided by 4, okay? So if we solve this, we have when 2 divides, okay, when 4 divides this, we have 1, right? When 4 divides 14, we have 3 remainder 2. If it divides 24, we have 6. So it means that the area of the quadrant should be equal to 36 pi square meters. All right, fine, we have gotten the area of the quadrant. Now let us find the area of the bigger semicircle, okay? So the area of the bigger semicircle should be equal to pi r squared divided by 2. Since the semicircle is half of a circle, so we divide the area of a circle by 2. All right, now remember, now the radius of the bigger semicircle is from here to here, right, which is half of 12. That should be 6. Now let's go back and get the value. All right, now that means that the area of the bigger semicircle should be equal to pi multiplied by 6 squared divided by 2, okay? So AB should be equal to pi times 36 divided by 2. Now when 2 divides 36, we have 18. So the area of the bigger semicircle then should be equal to 18 pi square meters. Okay, now let us keep that one, and then this is where the whole thing is difficult. How do we find the area of the smaller semicircle, AS? Okay, AS is equal to pi r squared divided by 2 as well. But the problem is, how do we get the radius of the smaller circle since it's not given? Now let's go back to the diagram. If you go back to the diagram, this is the smaller circle. The radius is not given, right? But the radius of this one is given. Now let us draw the two circles, semicircles out. If we draw it out, we have something like this, okay? And something like this. Oh, just let's manage it like this, okay? Then this is the center of the bigger semicircle, and this is the center of the smaller semicircle. Now if we draw a straight line, this is the meeting point of the bigger semicircle and the smaller semicircle. All right, if we draw a straight line through that meeting point, that means we have drawn a tangent, okay? And if we draw a straight line to pass through that meeting point from the radius of this circle through the meeting point, sorry, this is where the meeting point is supposed to be. I'm not doing this with a rule, I'm sorry about that. So if this is the meeting point of the two circles, all right, and this is the middle of the bigger semicircle, let me draw it like this so that we understand. Both of them is going to form a right angle triangle with the chord, with the tangent, this. All right, now this line, they will form what? Right angle with the straight line, and that makes them to form a straight line between both of them. So they're going to form a straight line together. That means we are going to have something like this. Let me draw it out. All right, whereby this is the midpoint of the smaller semicircle, and this is the midpoint of the bigger semicircle. Now remember that from here to here is the radius of the semicircle, the bigger semicircle, which will give us 6. Since from here to here, which is the diameter, is 12, the radius is 6. Okay, now let us call the radius of the smaller circle r. Now that means that from here to here is 6, right? This is their meeting point, which is this place. Okay, now that means from here to here should be radius of the smaller circle, right? Let's call it r. Now if we complete this diagram this way, all right, we are going to form a right angle triangle. We are going to form a right angle triangle. Now let's go back to the main diagram. If you go back to the main diagram, you will notice that from here to here is 12, right? That is the radius of the quadrant. From here to here is 12. Now from here to here is r, the radius of the smaller semicircle. Now if from here to here is r and from here to here is 12, so it means that from here to here should be 12 minus r, right? So we have 12 minus r. Now let's go back to this. So that means that from here to here is 12 minus r, right? Yeah, now let us complete that here. So we have 12 minus r here. This is a right angle. Now from here to here is half of this 12, which is 6. So it simply means that from here to here is 6 as well, right? So we have 6 here. All right, now notice that we have a right angle triangle now. Now if we use the Pythagoras theorem, the Pythagoras theorem states that when you have a right angle triangle, this side facing the right angle is your hypotenuse. Now the hypotenuse squared, in this case, is going to be r plus 6 squared, right? R plus 6 squared is equal to this squared plus this squared. So it's going to be 12 minus r squared plus 6 squared. Okay, yeah, according to Pythagoras. Now let us expand this. For you to expand a plus b squared is equal to a squared plus 2ab plus b squared. Okay, and a minus b all squared is equal to a squared minus 2ab plus b squared. Now let us expand. That means that r plus 6 squared should be r squared plus 2 multiplied by 6 multiplied by r, which is 12r, okay, plus 6 squared, which is 36, is equal to, now to expand is going to be 12 squared, which is 144, minus 2 times 12 times r, which is 24r, plus r squared, then plus 6 squared is what? 36. Now please click the subscription button, turn on the notification bell if this is the first time you are seeing this amazing channel. Please give us a thumbs up if you're actually enjoying this video, and always tune in at your convenience. There must be something new to watch. Okay, thank you very much. Now we have arrow squared here and arrow squared here. So arrow squared, we remove arrow squared, right? Okay, the same thing here, we have 36 here and 36 here, the same sign, so they will remove each other if we should transpose them. Now we are left with 12r is equal to 144 minus 24r. So we have 12r is equal to 144 minus 24r. Okay, let's continue from here. So we have 12r is equal to 144 minus 24r. Now let us add 24r to both sides. So we have 12r plus 24r is equal to 144 minus 24r plus 24r. Okay, now 12r plus 24r, so we have 12r plus 24r will give us 36r is equal to 144. Now minus 24r plus 24r will give us 0. So we divide this side by 36 and this side by 36. Now 36 we divide itself to give us 1. 1 times r is r. So we have r is equal to 144 divided by 36 will give us 4. So we have found the radius of the smaller semicircle. Now let's go and find the area. Remember that the area is pi r squared divided by 2, right? So it's going to be pi multiplied by the radius is 4, so 4 squared divided by 2. So this is going to be equal to pi multiplied by 16 divided by 2, which is equal to pi 8, right? Or 8 pi meter squared. Now let us collect everything. Remember that the area of the shaded portion is equal to area of the quadrant minus area of the bigger semicircle minus area of the smaller semicircle. Okay, so the area then should be equal to the area of the quadrant gave us 36 pi meter squared, right? So we have 36 pi meter squared minus area of the bigger semicircle gave us 18 pi meter squared, 18 pi meter squared, and the area of the smaller circle gave us 8 pi meter squared, 8 pi meter squared. So the area of the shaded portion should be equal to, let us factorize pi out, right? So when this is divided by this, we have 36. When this is divided by this, we have 18. When this is divided by this, we have 8, right? All in meter squared, right? So the area should be equal to pi bracket 36 minus 18 is 18, and 18 minus 8 is 10 meter squared. So the area of the shaded portion is 10 pi square meters. Okay, thank you so much for watching. See you in my next video. Bye.